Let's go over the examples from section 1.5. These are in the textbook on page 226. We're going to start with number 8, which I guess actually appears on page 227. Use the given conditions to write an equation for each line in point-slope form and then slope-intercept form. Okay, so in number 8, we're asked to find the line passing through the point minus 4, 2 and perpendicular to the line whose equation is y equals 1/3 x plus 7. So we're given a line and a point. So I'm given the point minus 4, 2, and I'm asked to find the line perpendicular passing through that point and perpendicular to y equals positive 1/3 x plus 7. Well, the line I'm looking for is perpendicular to this line, so I know the slopes will be opposite reciprocal. So instead of positive 1/3, it's going to be minus 3 over 1, or just minus 3. Because I'm dealing with a perpendicular line, I like to draw a little symbol here, and that little symbol actually just means perpendicular, right? It looks like two perpendicular lines, like an upside down T. And it's just reminding me that this line is perpendicular to it. So that's the perpendicular slope. And I'm given a point, so I can find point slope. The point slope equation very easily. Y minus y equals the slope times x minus x1. So minus a negative 4. There's the point slope form. To find the slope-intercept form, I just need to solve for y. So I'm going to distribute. Now I just need to add 2 to both sides. I get y equals minus 3x minus 10. These two lines are perpendicular to each other because the slopes are opposite reciprocals. And I know this line passes through this point, well, because we did the work to show that. So there's my solution to number 8. Next up, we have number 10. We're still asked to find a line meeting given conditions. First in point slope and then in its general form. Okay, so in number 10, I'm asked to find the line passing through minus 1, 3 and parallel to the line whose equation is stated here. All right, so this time parallel instead of perpendicular. My final answer will be in the general form of the line. So what I am given is minus 1, 3, and I'm supposed to find a line parallel to 3x minus 2y minus 5 equals 0. Well, I need to know a slope for this line. And the easiest way to find the slope of this line is to put it in its slope-intercept form to solve for y. Because then I'll see that nice, happy y equals mx plus b format. Add 2y to both sides and get 3x minus 5. And I realize that doesn't look much like a 5 even to me, so let's see if I can fix that. Much better. All right, let's divide by 2. So the line I started with has a slope of 3/2. Parallel lines have slopes that are equal, so the line I'm looking for also has a slope of 3/2. All right, so this time I'm asked to find a general equation of a line that goes through this point and has this slope, but I'm still going to start in point slope form because I have the slope and a point. All right, I'm going to distribute the 3/2 through. I'm going to add 3 to everything. Kind of working on an angle here. Y is equal to 3/2 x, and now the 3 over 2 plus 3 says 3 over 2 plus 6 over 2, so plus 9 over 2. All right, so what I've actually managed to do now is to find the slope-intercept equation of a line. But I'm supposed to find the general form. So I'm going to get 0 on one side. So I'm going to take y away from everything. And now I'm going to multiply everything by 2 just to make my line as nice looking as I can. Get rid of those fractions. Multiplying everything by 2, there's my nice happy general equation of that line. So here, parallel line, I have point slope. I actually did find the slope-intercept form, and now I have the general equation of that line. Next up, we're asked to do problem number 14. Number 14 asks us to find the average rate of change from x1 to x2. The function we're given is f of x equals 6x. And I'm told that x1 is 0 and x2 is 4. Average rate of change is a slope. So all I have to do is find a slope. So I need 2 points, so I'm going to plug 0 in and get out a y. Now I know the point 0, 0 is on my function. I'm going to plug in 4. 6 times 4 is 24, so the point 4 comma 24 is on my function. We just find a slope. The average rate of change is 24 minus 0 over 4 minus 0. Well, that's 24 over 4 is 6. The average rate of change is 6. Now, I brought in an example for this video, for this weekly problem set that I wrote. So this one's not out of the book. This problem is linked in our Moodle course, so you can look at it there, and my handwritten solution to it is also linked. But the data in the accompanying table summarizes a long trip. So time and distance. Find the average rate of change from the beginning of the trip to 3 hours. Find the average rate of change over the time interval between 2 and 4. Find the average rate of change for the whole trip. Well, from the beginning of the trip to 3 hours, well, time equals 0. I've gone 0 miles. Didn't go anywhere yet. And at hour 3, I've gone 150 miles. So I have 2 ordered pairs that I can get from the actual data, and I just need to find a slope. $150 divided by 3 is 50, and I need to use units here. The y values are in miles, the x units are in hours, so these are miles per hour, which I could write as miles per hour, or I could write them the way we typically do as mph. Both are correct. This one looks a little more like how we're actually thinking of this as a rate of change, but this abbreviation is just fine. 2. I'm supposed to find the average rate of change between hour 2 and hour 4. Again, I need 2 points, so 2 100 and 4 210. The average rate of change, still just a slope. 210 minus 100 over 4 minus 2. That gives us 110 over 2, which is 55, and the units are the same as last time, miles per hour. All right, finally, the third one, we're supposed to find the average rate of change for the whole trip. So that would be from hour 0 to the last hour, hour 5. Again, the average rate of change, just a slope. 220 minus 0 over 5 minus 0. 220 divided by 5 is 44, and again in miles per hour. Units are always important. Don't forget the units. Video right under this will be the problems from section 1.6.